Hi everyone, welcome back to my channel. My name is Arvin Nichi, and today I will talk to you about how to start a permission network. In this tutorial, you will learn how to build a permission network with Substrate by using the node authorization palette. You are probably already familiar with the public or the permissionless blockchain, where everyone is free to join the network by running the node. In a permissioned network, only authorized nodes are allowed to perform the specific activities, like validate blocks and propagate transactions. You can see some examples of where permission blockchains may be desired. Okay. You can see the private networks and highly regulated data environments such as the healthcare, the B2B legals, and the testing pre-public network at scale. Before you start, we expected that you have completed the Build a PoE Decentralized Application tutorial. Is in the Lesson 3, Build a Proof of Existence DApp. And you are conceptually familiar with the peer-to-peer networking in Substrate. We recommend completing the private network tutorial. You need to get experience with this first. Now what we will be doing before we get started, let's lay out the objectives of this tutorial. Number one is modify the node template project to add the node authorization palette. And task one is launch multiple nodes and authorize new nodes to join. And learning outcomes, you can learn how to use the node authorization palette in your runtime and learn how to create a permission network consisting of multiple networks. Now we add the node authorization palette. The node authorization palette is built-in palette in Substrate's frame, which manages a configurable set of nodes for a permissioned network. Each node is identified by a peer ID, which is simply a wrapper on the vector inside 8. Each peer ID is owned by an account ID that claims it. They are associated in a map. With the palette, you have two ways to authorize a node which wants to join the network. At first, we can join the set of well-known nodes between which the connections are allowed. You need to be approved by a governance or a pseudo in the system for this. And you can ask for the peer-to-peer connection from the specific node. This node can either be a well-known node or a normal one. A node associated with the peer ID must have one and only one owner. The owner of a well-known node is specified when adding it. If it's a normal node. Any user can claim a peer ID as its owner. To protect against false claims, the maintainer of the node should claim it before even starting the node, and therefore revealing their peer ID to the network that anyone could subsequently claim. The owner of the node can add and remove connections for their node. To be clear, you can change the connections between well-known nodes. They are always allowed to connect with each other. Instead, you can manipulate the connection between a well-known node and a normal node, or between two normal nodes and sub-nodes. The node authorization palette integrates an off-chain worker to configure its node connections. Make sure to enable off-chain worker with right CLI flag, as off-chain worker is visible by default for non-authority nodes. Now, we can build a node template. To get started, we can clone the node template if we don't have it. Okay, I will copy this code here. Yeah, I have a folder subtrade node template in my folder, and then I will go to this folder, substrate node template. Now we can build it and open it with your favorite editor, and let's make some changes. Because this file is existed by previous lesson and I can skip this. Now we can add the node authorization palette. First, we must add the palette to our runtime dependencies, and I will use the visual code here. Now we can go then. Okay, I will open the file runtime cargo time. Yes, this file, and you can see you can add the palette node authorization here. Palette node authorization, this line, and you need to add the palette node authorization in the std. You can see that here. SD, yeah, you can copy and paste here. And then we need to simulate the governance in our simple blockchain. So we just add a sudo admin rule, configuring the palette interface to ensure root. In a production environment, we should want to have governance-based tracking implemented here. More details of this config can be found in the palette reference docs. Now we open the runtime src lib. Well, in this file we can copy the new variable. Yeah, and copy this here and copy to this place. Yeah, and you can see the parameter types is a new one, so you copy this paragraph to somewhere in the under the code here, and see the type, parameter type there. Okay, I will search it. Now you can see many lines contain it. So after this line, you can copy this paragraph here. Copy group to this place. Okay. Now finally we are ready to put our palette in the contract runtime Marco with the following extra line of code. You can see the contract runtime and search it. Yeah, there it is. Now we can copy this line and add it to this place. Okay, now we add the Genesis storage for our palette. Pure ID is encoded in the VS58 format, so we need to new library VS58 in Node Carcaton to decode it to get its bytes. Now we can see the node in the cargo file here, and you can copy this to under the dependencies. Here, you copy and paste here. Yeah. Now we add the proper Genesis storage in the node src transmaps. Similarly, import the necessary dependencies. Now we can find the transmap here and copy this. You can see. Okay, and now we adding our Genesis config in the helper function. Now we can copy that paragraph to the helper function here. Yeah, you can copy and paste here. So now all the code changes are finished. We are ready to launch our permission network. And in the next section, we will use the well-known node keys and pure IDs to launch our permission network and allow access for other nodes to join. So you can view it. In this line, you can see the subkey generate. And if you do not install it before, you can go to this page and now you can install it. Can install it by this line. Yeah. If you do not install it before, you can install with the cargo and copy that and copy this line and run in our command line. Okay. Here you can copy this code and press your password. Then you can install it by this line. And after that, you can install the subkey here. Just so now, when you install the subkey and build your node template, you can already to start your node. Now we go to the inspecting keys. The inspect command, we calculate a key pair's public key and public address given its secret seed. You most commonly inspect the key by the mnemonic phrase that is used to derive it. Okay, this is the introduction about subkey, and we go to the main lesson in the start the permission. So, and next you need to launch your permission network. After you build your node, you go to the obtain the node key and peers ID. Here is some information about the Alice node, Bob, Travis, and the date. We can copy the BS58 decode purity for use. I will note the Alice here. And Bob. Can use for insert this purity to your Polkadot Explorer at the palette. Now we have a checklist. And last one is Dave. Okay, the notes of Alice and Bob are already configured in the Genesis storage and served as well-known nodes. We will later add the checklist node into the set of well-known nodes. Finally, we will add the connection between the checklist node and date nodes without making date node as well-known node. Now let's start. At first, we will start the Alice node. Okay, I will run this command. Now you can see some information. You can see the local node identity, and you can see, yeah, it's for to start at this address at the port listening in the 9944. Okay, now we go to start the Bob node. Okay, you can see the last one we had 0 peers, and when we start the Bob node we have a 1 peers, and you can see the block it is increased by the time when we connect the Bob node. Okay, we go to the Potato.js Explorer. Okay, we go to the local node at the 9944. It's the Alice node. And then what we will do next, we go to at the date. Alright, in this train state we can see the key of the Alice and Bob. Okay, I will go to the storage, train state, and storage. And the owner, well-known node. Okay, you can see. And we can query the block hash here. So if I click the plus signal here, you can see the well-known node. And you can see 1 key for Alice, 1 key for Bob, and 1 key for Charlie because I make it the well-known node. And now if you make the Charlie well-known, here, run the date node. Okay, because it's a well-known node and it is connect with the Alice and Dave, Alice and the Bob node. And how to make it a well-known node? You can go to the sudo and go to the node authorization, well-known node. With Charlie and copy the hash code of Charlie here and submit it. Okay, it's already to join. And now you can add date as a subnode to your chocolate. You can run the date node. Okay, you can see the one pairs because they only connect with the chocolate node. And how to do that? We go to the intrinsics. Here, intrinsics. So go to Dave and node authorization and next you can add connection. Okay, you can use the chocolate and add connection. You can copy that address and copy the day address here. Okay, and you can submit the transaction. Okay, after that you can use the date and go node authorization and claim node, and you can copy the date PRID here. Okay. And submit transaction. Gets it already to claim. And last one, you can connect the day to the chocolate. And submit transaction. Okay, and you can see one pair because the chocolate connect with the day. If you stop the day and you can see it's down to 2 pair. Now I will start the day here. One pair, and now I stop. I will stop the chocolate. It go to 0 pair. Okay, and it's go to 1 pair. Now it's 1 pair. because Alice and Bob is connection together. Okay, it's all about today's lesson. Thank you for listening and see you in the next video. Goodbye.